Hi, welcome to my talk. This is structured tenancy, isolating data in Cash App with coroutines and DI. So this is a talk about shipping. It's a big war story talk. And when we're talking about shipping, we're always talking about a balance between bold, confident change and honoring your existing commitments. And just as a case in point here, here's a picture of me and my son, Cassidy. That's me. That's my son, my wife and I's 4-month-old son. And I've been going by Bridget, she, her for a while now. I came out at work like a month ago. While Cassidy, on the other hand, has been waking up every hour or so, and I literally have not had time to update my bio page or anything. And so honoring existing commitments here is that my conference bio says Bill on it, and bold confident change here is this slide. Moving on. Cash App has a login flow. Like at the beginning of this story, if you opened up Cash App, you installed it, the email address, you would see this blocker that would ask you to enter your email address or your phone number, right? And then it would challenge you and send you a code. And then you'd enter the code, and at that point, you would be authenticated, right? So we've had a session token this whole time, but once your session token is authenticated, you can do things like query feature flags, get configuration information, account metadata, all that kind of stuff, right? And then you go on and continue in the onboarding flow, and you eventually get into the app. Later on, if you want to sign out, you go to the settings page, you hit the sign out button, you hit OK, and then you go back to the beginning in this selector that lets you select the account that you previously signed into. So backing this was a really simple DI graph. We had an app component and main activity component. App component was a singleton instance. So everything in there lived for the entire lifetime of the app, right? And backing that stuff was persistent storage that was also singleton-y, right? It lived forever, essentially. So what happened, since all of this is bound at the same time and the same thing, what happened when we signed out? Well, the way it worked was you kind of did it by hand. We had mechanisms like database triggers, async signals, and some synchronous cleanup hooks. The async signals let you do things like cancel coroutines or RX Java calls, right? But all of them effectively amounted to hooking up your cleanup by hand. So the natural question is, why did we do it this way, right? And this is kind of a design architecture question. And whenever we're answering design architecture questions, I always want to emphasize that there is no right or wrong architecture. If you're looking out at the broader world of architecture and what's a great architecture? What's a good architecture? What's a bad architecture? These are meaningless questions. There is no right or wrong architecture. Code serves customers. So your architecture is right in so much as it serves your customer needs. So what were our needs at the time that we built this? Well, the old cash goals, first and foremost, like any early company, is to survive. We lived inside of Square, but our survival was not guaranteed. I wasn't around for this phase, but I was kind of towards the end of the beginning of things. I was there. So we kind of built the simplest thing that could possibly work, as evidenced by this. That meant don't think about Dagger, right? We wanted to just write our code and not think about Dagger problems. Flexibility was extremely important because you didn't know what the shape of the app was going to be. You wanted to have the freedom to pivot. So don't constrain your code more than necessary. And then flat ownership. We had a small team, and that meant don't police your colleagues. Give them the freedom of motion to do what makes sense to them, and through organic connections, we'll know what is going on with everybody, right? But these needs do change. The first most important thing that changed in this story was user experience. So we got a need to build out this experience. So say we're in the main payment pad, right? You go to the settings page. There's a little drop down that says Bill Jings on it. You tap that, a bottom sheet comes up, and it has a list of other accounts associated with your account holder. If you tap on one of those accounts, you see a spinner, says hello, and we're in the other account. There is no validation step. really nice customer experience, answers a lot of problems. But let's compare to what we had in this other flow that we just looked at. In the other flow, we have this whole section of the flow where we're not authenticated anymore, right? We don't need to have anything around, right? While in the new flow, we're proceeding straight through the whole thing. Now in both of these, in the old system, we have to run this code that wipes things, right? And if you have this unauthenticated period, that's not a big deal. But if you're switching accounts, that's like this point in time where you're wiping things, and that results in two problems. The first one is races. Anytime you have something that is like happening that is a single point in time, things are different before and after, you've got a problem when things cross that line. And that was one thing that we saw. We were able to work around it, but it's not a comfortable place to be architecturally. The other problem is waste, and specifically two kinds of waste. Like we're talking about network time and network money. All that data that we're throwing away, we're still validated to use it. Our account token has access to that. We're just throwing it away because we're looking at another account now. We could put it to the side and then switch back to it and not ask the network for it, save a lot of money, save a lot of time. Another thing that was changing was customer usage. And this is something that is really important in the life cycle of a company. Your customers' usage of your app may change. One thing that popped up that was a bit of a surprise for us was shared devices. People would use Cash App, sign out of Cash App, hand it to their friend, they would sign in, and they would use Cash App and hand it back. That was happening, most people stayed in the same account the whole time, but there was a subset of people who were doing this. Caught us off guard a bit. Our app was also just becoming more central to our customers' lives. So we were building out banking services. Our network was growing stronger, so people were living more of their financial lives in the app, right? And then we just have flat out more customers. All of these things increase risk. They increase risk both from the standpoint of the probability that some big problem is going to happen because you have more people using the app, and also increase risk in the sense of that for an individual, since they're bought into the app more, an issue with the app more is more severe than it would have been before. So that risk factor is going way up, where in the early days it wasn't a big deal. And then finally, you've got engineering externalities. If you've been in a growing company, you've seen this stuff, but we went from less than 10 engineers to, I did a count on our internal tools, we've got about 20 mobile teams. I didn't even count the engineers. That results in communication silos and less ownership in common, less context for each engineer. And then it just flat out more code to deal with, right? So those OG cache goals are some of them are kind of broken. The simplest thing that could possibly work, we still want to keep things simple. Maybe not the simplest possible thing, but we do want things simple. Flexibility, it's not as important because we know what the core flows are. They're not going to change. This question of what is constraining more than is necessary, that's a question that the answer is going to change to. And then flat ownership, it's like boiling a frog, but that goes out the door at some point. Don't police your colleagues. We were policing our colleagues all the time. So these goals didn't apply, and we kind of had informally new guidelines around simplicity. That was still important, right? Don't think about Dagger. I think it's still a value for us. Safety, a lot more important. Don't build foot guns. If you've ever seen Jeff Atwood's Pit of Success idea, key idea, really important for us designing this new thing. And then independent teams. Don't assume shared ownership. We were less and less able to do this. So these two things, these are really complementary. Simplicity also is complementary with this idea too. So these kind of feed off of one another. So let's get into the plan. And we'll start off with object lifetimes. So here is what we had above, right? Now let's take this and look also at the parts where we're signed in, and let's name this unauthenticated portion of it. Let's give it a name. Let's call it onboarding. And the parts where we are authenticated, let's call them accounts. This big idea is what we call the phased graph, right? And in terms of our DI graph, the intention was for it to look like this. We would have an app component, which was still a singleton, and then an onboarding and account component hierarchies that reflected what we had before. Those dotted lines there, those reflect that those connections are component dependencies, which if you're familiar with Dagger, they're basically a higher friction way to hook up two components. So if you have a component dependency, if you plug something into app component, it's not automatically visible. You have to explicitly make it visible on the component. While these are the child component connections, they're very low friction. And the reason we wanted to do that is because that singleton is going to leak data. We want to discourage engineers from putting it in there. If we didn't, it would be an easy default place for things to go. A lot of gravity code would just accumulate there. The advantages we saw of this phase graph at the time were things like strictness. We were able to say like, well, if you put things in the account scope, in the account component, then that limits where you can put things, and that makes it so that our basically nothing is accessing something that needs permissions that doesn't need it, right? Immutability. In the account phase, you have an account token. We can bind that immutably to one value that never changes in that component, and similarly, we can kind of make more non-nullable guarantees. We can build the account component, run our query to get our feature flags, and then whenever you query your feature flags, you know that if it comes back null, that the server actually told you it was null. We don't have that guarantee right now. Everything is more reactive than that. And then finally, we were also thinking about platform parity. iOS was involved in a similar effort, and they were spinning up their own dependency graph, and so this led us to do something that was going to be similar to what they were doing. Now, of course, you can't go directly from the thing on the left to the thing on the right here. You got to migrate somehow. So the only way to do it is to combine them. You can't wave a magic wand and just transfer everything over. So we combined them into one big Dagger graph, renamed our old app component to legacy app component, and started a migration plan. So some things in that legacy app component we're going to move to our singleton, and then most things we're going to move over to either the onboarding or the account component, right? And then once we burn down legacy app component and main activity component, we'd delete them, and we would be done, and we'd be in our goal state, right? One tricky part here is you'll note that account activity component and onboarding activity component have two parents. You can't really do that in Dagger. So this is some shenanigans what we got up to. This is how those shenanigans work. So for account, for example, we had this interface migrated to account that was implemented by account component. So anything in migrated to account shows up in account component. And then account component is passed into account activity component in its builder. And then we have this other module that gets plugged into the account activity component called migrated to account module. Now say that I wanted to publish my coroutine scope such that I can access it inside both account activity component and account component. Well, I'd add it to migrated to account, and then I'd add a provider to migrated to account module that pulls that out of the migrated to account interface. And then we're visible there. This, isn't that cool? It's a big giant hack. It works. That's all I can say about it. Next up in the object lifetime thing is the work of managing work. So we've got our components here, right? We've got one that's active at any given time. And when I'm thinking about any long-running work in coroutines land, I like to model that as suspend funds. That's my love language. So I'll think of an account component as a suspend fund and an onboarding component as a suspend fund. And I've also got a little coroutines algebra that I get to do here, because a suspend fund, you can also think of it as a coroutine context. That's kind of an equivalent view of things, if you've got a coroutine scope inside of that. And a coroutine scope is identical to a coroutine context. They're the same thing. If that idea is new or interesting to you, see Stephen Edwards and I gave a talk on this a couple of years ago, and you can see me get into that in more detail. But looking at it from that perspective, we can also see that we're going to have one of these active at all time, exactly one. So we can model this as a state flow, which is pretty cool. So here's the big idea. We want to have a state flow that each entry has a coroutine scope. My favorite tool to do something like that is Jetpack Compose. So we'll create a phase key to identify each entry in the state flow, a state flow of those phase keys, and then plug that into a composable, and then create an output phase component, right? And then we'll go to our Dagger graph and wire it up with molecule. Perfect, awesome, easy, right? Didn't work. It didn't work at the time. It might work now. I haven't talked to the Compose folks about it, but at the time I did this, it hung on app startup. Something was going wrong in the Compose internals. So we had to roll our own. And that is this ugly piece of code, which I'll break down a bit for you. Focus on this scope.launch here. Since it's undispatched, we should proceed directly through it without suspending. And we should hopefully then continue on through these following lines to construct our initial output value, which we then plug into a mutable state flow assigned to that variable, and that should then be non-null when we exit this. So we've created a state flow and started running a coroutine to populate it with new values without dispatching. The problem is that this doesn't work. And it doesn't work because collect latest suspends. So that breaks our plan here, which we then fix by, again, rolling our own, wrote a collect latest undispatched. And that's this, again, a little bit of gross code. I'm not going to get too much into this, except to say that it does work. Effectively, all we're doing here is running an initial job separately, emitting that, and then doing a collect latest, and then running subsequent ones when they arrive. So that creates our state flow. That's got all this set up, and the next job is to connect this to the actual coroutines running in the app. Now, if your app is like ours was at the time, you may have some stuff that is wired up like this. So like real event consumer, when we started this, it was a singleton, so just create a scope, not a big deal, right? Who cares? This, though, is a time bomb for us, because if this lives inside of our phased graph, when we shut down our phased graph, this scope is still going to be alive. This is a structured concurrency violation, and again, we didn't care about that before, but now we care about it a lot. So we got to get rid of it, which is simply a matter of switching to injecting this from our dependency graph. So I'm not going to dwell too much on this. I love structured concurrency. I will just do a couple slides on this. Reasons you want to lead hard on structured concurrency. Easy cleanup is really easy. You don't have to think about it. It just happens. If you cancel the parent scope, everything hanging off of it dies. Hard things are possible. If you need to clean up on a specific thread or dispatcher, you can do that. It's possible. The caller can even manually clean up if you like, similarly to destroy, if you really need to do that. You can manually hook up a job. So anything that is difficult, you can do. There are some reasons to violate structured concurrency, like maybe you can't include coroutine scope in your public API. I get it. Maybe you're already violating it and I don't have time to change it now. You know, we all live in a society. It's just the way things are. But I do see some special pleading sometimes from people who are like, oh, I know what I'm doing the right thing. I just want to remind you, boring is better than clever, same is better than different. Do something like this and your life will be better. So, the last thing we have to think about, I'm rushing through, I got so much content to get through, but the last thing we got to think about is this thing, the navigation container. It's in a one-to-one relationship with our main activity. And it has a backstack, and in the backstack it has a bunch of screens. This is like a detail of our internal navigation system, but each screen is a parcelable data object, and we take those data objects and sort of dereference them in the dependency graph to get an implementation, right? So these actually, even though they're simple data objects, they correspond to something in our Dagger graph, right? And that backstack could potentially span across account and onboarding, right? That does happen at some points in the onboarding flow. We just kind of scratched our heads at this and said, oh, it'll be fine. What could go wrong, right? And then the other problem that we had is like swapping out that component, right? You need to unregister it when the component passes out of scope, and then register the new one when it passes into scope. And we solved this problem like all great permanent solutions are implemented with mutable state. Nobody ever regretted using mutable state. So we celebrated, everything's great. Let's throw a party, have a lot of fun, ship this thing, and someday later on, we will look on this whole experience fondly. These are, of course, stills from the hit movie Titanic, used transformatively for jokes. Moving on, so we've solved that problem. Our next big problem is the storage. So we had this storage situation where everything was living in the same place. These are all stills from our debug app, where we do have kind of a sandboxy thing going on with staging and production, right? That's an environment key. It's kind of not fit for purpose for us here. One big reason is that it's statically injected, so we can't actually dynamically switch it out, which we would need to do. The way we switch it out in our debug app is we reassign that and then kill the app, right? Can't do that in production. They're also hard-coded. Sandboxes need to be dynamically allocated, and that bookkeeping around those dynamic allocations needs to be bulletproof. We also need a cleanup mechanism. Like, when you allocate a new sandbox, you're on the existing sandbox, so you can't just delete it out from under you. You need some way to mark sandboxes as being dirty so you can clean them up later. So we did this with SQLite, created a little table called storage link. It has an account token, so you can look up a sandbox later when you need it, and then an ID, and sign-in group ID is our cleanup mechanism. I'll talk about that more in a few. And then finally, we also need to ensure that we never sign customers out. We need some way to ensure that their active storage link is persisted. So we did this by leaning on shared preferences, which that's our stable storage link. I'll talk about shared preferences more later. I'm sure you'll enjoy all the wonderful things I have to say about shared preferences. So there's our sandbox, sandbox 2. There's our application scope database, which we need to have because we need some place to put that storage link table, right? But we still have the old global scope locations sitting around. Like, what do we do with this? When we ship this, customers are going to have data living in it, and it's really important that we don't accidentally sign them out. So we've got two approaches for how we can solve that problem. We can either do some blocking operation where we stop the UX and move it over, or we can just leave it where it is. We looked at this and said, blocking and moving it over, that sounds hard. Let's just not. Let's just leave it where it is. So what we did was we modeled the existing location with a storage link we called legacy. It kind of had a no-op ID and sign-in group ID. And now everything that we have in our persistent storage has a name and a reference. Great. So let me put all this together to you so you can see how the whole storage system works. If we ship this and you're on legacy and sandboxing is turned on, then you're going to start in legacy, and then when you sign out, we will allocate a new sandbox. And initially, because we don't have an account token for the account you're signing into, we're going to mark the account token null. This is a special sandbox that we call the onboarding sandbox. Because we don't have an account token for it, it's kind of unowned, so we only ever want to have one that has a null account token at any given time. So we assign that, we live in that sandbox for a while, and then when we finish authenticating, we write the account token we get in authentication into the database, and now we're good. If you then later decide you want to sign out from that account into another account, well, you sign out, the same thing happens with allocating a new onboarding sandbox. And this time you'll note that we increment the sign-in group ID. This is that garbage collection mechanism. The way that works is that the The highest sign-in group ID is the active one. Everything that is not the highest one is garbage. It can be cleaned up whenever we're ready to do that. So that's incremented, that's garbage. And we're going to continue on in this flow, and when we hit that authentication step again, we'll write that in, and then at some point in this process, we'll wipe out that other row, and then at some point, we'll synchronize the state on disk and wipe out all of the associated storage there. We'll delete the associated folders and share preferences and all that. Now, the last thing that we wanted to address is safety. So we've got a bunch of engineers, right, who are doing who knows what, and we've got pretty much everything else in the world that needs a file, right? And in the old state of affairs, everyone who needed a file or a file-like thing would access it through context file APIs. And from a safety perspective, we really didn't want this for our internal usage because you can break out of that sandbox, right? However, we still needed these APIs because all this other stuff out there, it's going to be okay. They're not going to break out of the sandbox. But we still need to support it. We need to have that context API. So we needed a solution for our internal engineers. Now it turns out, OKIO has this really cool tool called forwarding file system. And in forwarding file system, you can, when a path is requested, rewrite it. So that's what we're doing here, is we're forcing this path back into the sandbox and rerouting it and resolving it. And we create a different instance of this where files, cache, temp, these correspond to the same methods on context. They're just like locked down, right? And we have this interface storage where we assign one instance of this to each of these, and we have another API for getting a file URI, and those file URIs are used for other kind of interop scenarios. So now we've got that problem solved. So let's try to ship it. What could go wrong? So you may recall this slide that I used all of the Titanic stills on. I've got one more Titanic still from the hit movie Titanic, used transformatively for jokes. This is where things are really going to go sideways. The first reason things are going to go sideways is because of where things get published. So a lot of things really clearly belong to the account component, right? A lot of screens only should be used there. And we have other screens that really should only be used during onboarding. But we've got a lot of screens that can actually be used in both. So this verification screen, we use this while you're signed in as a double check sometimes, right? So that means we have to double publish it to both components. Which, okay, that works. But what if you forget to do that? Well, if you forget to do that, then the way you find out about it is somebody tries to navigate to your screen, we go to the account component, try to instantiate it, and it blows up. That's not good. The other problem that we ran into is a problem of modeling, right? So this vision here where things abut clearly to one another and there's no gap in between them isn't really true for setup and teardown. You're going to tear down, and then you're going to set up, and there's going to be a gap in between the two. And we ran into situations where we'd go to something, and we would hit right in the middle of that gap, and it would blow up. We were able to patch over this. We were able to get it to work for most situations, but I'm sure you can imagine that didn't give me it didn't give me a real feeling of safety in my heart that this happened. I was like, this doesn't feel great. Also, if you think about our ideals that I talked about before, like this, does that really align with don't build foot guns? Does this really align with don't think about Dagger? Does this really align with don't think about Dagger? Absolutely not. Not at all. So we decided to abandon that and come up with a new plan. The new plan is essentially let the storage plan win, because you may have noticed that this diagram looks a lot like my component diagrams that I had before, right? So why don't we just make these our components and have the storage links hang off of them? If we do that, Then our new dependency graph looks like this. And this is a lot easier to think about migrating to. In fact, this is mostly just renaming the components. And then the app component, the singleton stuff, we proactively pull that out. And that's something that we don't need to rely on the entire organization to do. A very small set of people can kind of do that work, right? The other problem that we had related to, if you'll recall, where the navigation container lived. This also is solved by this plan, because we can take that navigation container and just move it inside the sandboxed component. When we start up the new navigation container that is completely fresh, we have a way to populate it, because we do that on cold start. So we just reuse that cold start code that we already have. The gap, I mean, we still kind of need to worry about the gap, but mainly because it produces a visual glitch for the customer, right? We're swapping out the old navigation container, and there's a period where we just don't have one, right? So what did I decide to do with this visual glitch? Well, you know, I decided to put something on top of it. So we have a little shim that just looks like a little cache logo that we paste on top, and it hides all of the gross stuff that's happening underneath with the navigation container. The same thing happens in account switch. That spinner view right there, it's not a real screen. It's just a fake screen that we put on top of things to hide all the stuff going on behind it. Now, doing this work was not really trivial, because it used to be that the main activity had a one-to-one relationship with the navigation container, and now it doesn't. It's a one-to-many relationship, and that was really, there were a lot of connections there. So it required a fair amount of work to do it, but we did it, and it works end to end. Great. One last thing, and I'm not gonna have too much material on this, but I do have to address it: memory leaks. Now that we're actually successfully swapping these components back and forth, not everything is going to behave perfectly from a memory standpoint. It's impossible to predict what is going to have a problem. A lot of things are just like dealing with third-party libraries, and they have weird statics in them or something like that, right? So you just gotta have a plan to go hunting, And what's your gun when you're hunting memory leaks? Would anybody like to shout your tool for hunting down memory leaks in Android? That's right. More obscure question. What's the best part of Leak Canary? What? Shark CLI. Does anybody know Shark CLI? Raise your hand. Shark CLI is the greatest. I love it. If you don't know anything about Shark CLI, go use it. It's fantastic. It was my buddy when I was in the trenches hunting memory leaks. So let's try to ship it. We've solved all these problems. Again, what could go wrong this time? Well, now our problems are a little smaller, but they're still real. Feature flagging is a big one. And we did kind of think about this earlier on, but one advantage of this new scheme was that we could feature flag it in prod, right? This is kind of what our state machine looked like for switching out sandboxes. I'm not going to go into detail about how this works, but tweaking that for feature flagging was really just a matter of adding this little bit here. It took us a few iterations to get there. Like a lot of design problems, we built something more complicated before we landed on something more simple, right? And then the other problem that we had is that our most tested feature flagging solution is the one that's associated with account tokens. That's the one that everybody uses for their day-to-day feature development. And we can't use that. And the reason why is, say you're going through this account switch workflow, right? And say that Bill Jings is getting the enabled flag and Bill Isness is getting the disabled flag. Well, when I go this way, I'm gonna go and get sandboxed, but when I flip it around, I'm gonna go back into legacy. So it's kind of impossible to analyze what's going on with the experiment. So we have to use a device scoped feature flag, use our app token that we vend out, right? And this is unfortunate for us because for cache, our analysis support for this really not as good as what we had for our account scoped feature flags. So we started trying to ship this, iterating on this, doing A/B tests, right? We have a weekly meeting, and here's a screenshot of my notes from January, right? And And this is what a lot of them look like. We're looking at a lot of metrics, seeing them moving, and talking about them, and seeing if we can understand what's going on, right? And you'll note that we've got a lot of regressions here in what seem like similar areas. So like login success, sign out confirm, switch account. These are all these touch points that we're talking about. Crashes are not elevated. Crashes are really, really flat. We're doing a good job there. So what's going on here? We were really at a loss because it almost looked like we were just changing customer behavior, but my spidey sense didn't really track with that. That didn't make sense. But I couldn't see any crash or anything that was going wrong. Like, I had maybe some hypotheses. Like, maybe something just wasn't working quite right, and our customers were self-solving by force quitting and pulling up the app again and trying again, right? So after a long time racking my brain about this, I eventually looked at our amplitude traces. And I wish I had some screenshots of this. I don't. So I'm just gonna make them up for you. Here's what they kind of look like. What we would see was stuff like this. We would see a cold start on Sandbox 12, and then an account switch where we'd switch into Sandbox 13, then a cold start again on Sandbox 12, and again a switch into Sandbox 13. So that was kind of what I was suspecting maybe was happening. Was it looks like they're starting on A, switching to B, they're starting on A again and switching to B again, like they're repeating what they're doing over and over again. Never able to repro this, not once, right? But I did have something I suspected. So just as an example, to give you an idea of how my brain was thinking, I moved at some point last year, and my wife, at the end of our move, she reached into a box of kitchen stuff and reached out, and her hand was bleeding. And we sent her to the emergency room and got it fixed up. But that entire time, we're like, what did you cut your hand on? What was it? So we get home, and what do? We throw the mandolin away. Why? We have no clear reason that we think it's the mandolin, but we hate the mandolin. That's why we threw the mandolin away. It turned out it was a food processor. We're not getting rid of the food processor, but we're happy we got rid of the mandolin. This isn't exactly analogous because I think shared preferences was the problem, but I hate shared preferences. They're kind of sus. SQLite is not sus. And in addition to it being sus, we've also just got the problem that we're tracking data in two different places, right? That doesn't feel right to me. Like, I was like, oh, it'll probably be fine. But then you start seeing issues in production. I don't think it's fine. Why do I think shared preferences are sus? It's just a big XML file. That's all it is. And it lies about I/O in the startup path. It does I/O in the startup path. Strict mode doesn't say it is. It is. My quiet hate for it, it goes on and on. Yet shared preferences, they stick around. But for me, I can kill them today. So that's what we did. Burned it with fire, and then moved everything into SQLite. Now we have an active storage link sitting in the SQLite database alongside our storage link, and this stuff is linked together with transactions. So I know that when I change one, I'm changing it all together, and I'm always in a consistent state. I sleep easily that way, and we tried to ship it. What could go wrong this time? Nothing. We shipped. Hooray. We started designing this thing in June 2023. We finally shipped it in March 2025. This was almost 2 years that this project went on, right? So the natural question that you should be asking yourself is, why did it ship? One big reason, it was defensible from multiple points of view. Performance was the initial big reason that we started on this thing, right? That sold the project. Cost also helped sell the project. But what helped it survive? Because, we went through layoffs, we went through big management changes. This feature that we built it for, it shipped. We hacked our way to get to the end, but safety was what got us over the line, right? Because that was extra important to have a foundation such that we would never have to worry about these issues ever again. Asking for help was another big reason that it shipped. At the beginning, we had so much design help from great Android engineers, like basically everybody that I knew in Kitchener-Waterloo helped out somehow. My colleague Igor also helped out a lot, but like all the good ideas that you see here from a design perspective, that's where they came from. All the bad ideas were something I invented on myself and tried to make work, and it didn't. In the early ship phase, it helped a lot to get help from people in this big migration we tried to do, because with everybody pitching in, we were able to see really quickly that it wasn't going to work. It didn't take long to reject that hypothesis. And then in the late ship phase, we got support on experimentation, both from like data scientists and other engineers to help run the experiment and keep focus for me on trying to debug this stuff. And then spreading ownership out so that when I'm debugging stuff, I can talk to people about how it works. They can have their own hypotheses, they can drive their own investigations, and it's not all sitting in my brain. Now, why did it take so long? Not asking for help. There were lots of periods of doldrums where I was just sitting by myself trying to do it hard. I can't recommend not doing that enough. 2-week A/B iteration times are punishing. If it takes you 2 weeks to find out there's a problem, 1 week to debug it without a repro, and 1 week to implement a fix, you've lost a month on your calendar. Really rough. Try and do as much as you can outside of the A/B testing experience. And then we had a lack of experimental analysis experience. Like, I had a fair amount, but I didn't have this experience with traces that we talked about, right? So that kind of hampered us. We learned that staring at metric movements, which we did for months, isn't enough. Like, sometimes it's enough, but when it's not, you need to look in other directions. Things I learned. Don't just ask for help. If your project is going on for a long time, reassess things. See whether you need to ask for help again. See if your needs have changed. In addition, if your project goes on for a while and it's going well, people are going to complete pieces of it and roll off of it. That's great. These people are going to want to work with you again because they're not like doomed to some death march. Try harder is always a failure mode. Another lesson, you can do a lot of really neat things with your DI framework. Don't. Attack production issues relentlessly from all angles. I've got a lot of great model engineers, like I get to like watch Jake hack on things, which is ridiculous. But what you see is just not settling for the answer you see right in front of you. Like, if I don't see an answer here, I'm going to come at it from another angle. Finally, change is easy early on. It gets harder, and like, I don't necessarily want to be like weird LinkedIn person about this, right? But shipping is more than just shipping code. Shipping is change, and change is social. All the stuff I talked about is a lot of collaboration, right? So any change that you do, it starts with someone who cares a lot about it, but you're not going to ship this thing. It's not going to be completed until you've taken everyone else in your company where you want them to go. That's when you ship, is when everybody agrees that we're done, right? So have fun, ship code, don't do anything I wouldn't do. Thank you so much.